Hello everybody. So today we're going to do guided notes with this video. Hopefully it's already on the smartboard and you have your blank papers. You will need tracing paper today, so either take that out of your binder or wherever you have it, or go pick one up from the front table. And then you're also going to need a little baggie of some colored pencils that should have been provided or will be provided very soon. So section 213 says more angles formed by transversals. We're going to just go through this. So 224, it says whenever one geometric figure can be translated, rotated, or reflected, or a combination of these, so that it lies on top of another, that figure must have the same shape and size. When this is possible, the figures are said to be congruent, and the symbol, an equal with a squiggle on top, is used to represent the relationship. So let's write the definition and talk about this a little bit. The definition is same shape and size. And then let's put that symbol there. I'm not liking this marker, so let's switch that. So basically the difference between congruent and equal is congruent are things that are congruent, shapes, like triangles can be congruent or cubes can be congruent, but equal is numbers, numerical values. So like the length of this side is equal to the length of that side. But you can also say sides are congruent, so the shape and size of this side is the same as the shape and size of that other side. So things that are congruent, yeah, they're basically like equal, but you would never say like this triangle is equal to this triangle. You could say the areas are equal or the perimeters are equal, but you would be talking numbers. So just think equal, it means numbers, and congruent means shapes. But you can also talk about like lengths. Sorry, not distances, that would be numbers. So part A, it says, review the angle relationships you have studied so far. Which types of angles must be congruent? So if we look back at our toolkit, we've talked about vertical angles, straight angles, right angles, or straight lines, whatever you wrote, or think about it as, it's up to you, it's the same. And then corresponding angles. So we know that vertical angles are equal, so that means they're also going to be congruent. So no, don't like that marker either. Let's see how this one goes. That's a little better. Vertical angles, and then also corresponding angles. And that was from yesterday. So part B, it says, angles are not the only type of figure that can be congruent. And we kind of already talked about that just a little bit, or I talked about it. It says, for example, one side of a figure can be congruent to another side. Also, a complex shape, such as a trapezoid, can be congruent to another if there is a sequence of rigid transformations that carry it on to the other. So like translation, rotation, reflection. Consider an isosceles triangle like the one shown to the right. Because of its reflection symmetry, what parts must be congruent? So they already kind of tell us here, these pieces are, so let's write that out. So normally we would write AB equals CB, but now since we're talking about congruence, we want to also talk about not numerical values for things, but the actual segments themselves. So we put lines over top of these, so like AB with a line over top is congruent to CB. And then I also, to make matters a little more complicated, I also like to keep the same order. So if I go from A to B in the first one, I want it to go from C to B in the second one to make sure that I'm creating that same order for the things that actually match up. So then we can also talk about, oh, that D is supposed to be right there. Oh no, sorry. So in class, you'll need to put that there. So here, let's fix that. This D goes right here. So we want to say AD is congruent to CD. And then if you really wanted to talk about the ones in the center, you could. So DB is congruent to DB. And we'll talk more about that in way later lessons, but that'll come up later. And then we can talk about angles. So angle A is congruent to angle C. So a couple of days ago, we talked about writing measure of angle A equals measure of angle C. The difference between this one on the left and the one on the right is the one on the right is talking about numbers. So measure of will give me a number. So measure of angle A is saying the numerical value for A is the same as numerical value for C. But on the left, it's saying literally angle A is the same shape and size as angle C. Some people think that's like all the same stuff, but they're different things, numbers and the shapes themselves. So that's why we have different ways of writing them. And then let's go back to our color. Then if we want to talk about the B's, there's a lot of B's going on. So I'm going to say angle A, B, D. So I'm following the dots, is congruent to angle C, B, D. Connecting the dots in that order will create those angles. All right, let's move on. So now 225 says, suppose angle A in the diagram to the right is 48 degrees. So we're going to put a 48 in our picture. It's really useful to be labeling these as you go. It's going to be really helpful in answering other questions. It says, use what you know about vertical, corresponding, and supplementary angles relationships to find the measure of angle B. So I am going to try to get this information from A down here so I can put it somewhere near B, so then I can see if I can find a relationship with that. So I'm going to take that 48 here, which is on the bottom left, and I'm going to put it again on the bottom left here because, oh, that's supposed to be an 8, sorry, because they are corresponding. So I'm going to throw that over here because that's something I used, so corresponding. And then I'm going to come back over here and say, okay, now that I put that in there, I can see that these are vertical angles and we know that they're equal. So the angle B is 48, so we're going to say, and then vertical are equal, so the measure of angle B equals 48. Okay, so now I'm going to just look at those two pieces. This was 48 and this is 48. So I just kind of cleaned it up so we can look at that because that's going to come up in the next part, some new information. Part B, it says, Julia is still having trouble seeing the angle relationships clearly in this diagram. Her teammate, Althea, explains, when I translate one of the angles along the transversal, so she's actually literally using tracing paper. We didn't do that in the last one. I notice its image, so the result, and the other given angle are a pair of vertical angles. We figured that out. That way, I know the angles A and B must be congruent. Use Althea's method in tracing paper. Determine if the following angle pairs are congruent or supplementary. Be sure to state whether the pair of angles created after the translation is a vertical pair or forms a straight angle. So you should have already taken out tracing paper, but take a few seconds to get that taken care of. I'll give you a couple seconds to find some, and then we'll do it. Okay, I hope you've done it. So if you haven't, hurry. So we're gonna take A, and on here it's not easy for me to show this actually physically doing it, so I'll just talk through it. But I'm taking this A and I'm moving it down along the transversal, which is that line right there. So you're gonna move that down with your tracing paper. When you do that, what happens is it ends up down, oops, didn't mean to use highlighter, ends up down here. A ends up there. So what is the relationship between A and B? Well, they create a straight line together. I got rid of this extra part so you could see it. So A and B create a straight line in this picture. So I'm gonna put that A back here. A and B create a straight line. And when it's creating that straight line, we know that A plus B equals 180. So then in the next one, we're going to do the same process of tracing A and then pushing it down until it hits where it's going to be equal, and it's actually going to hit before that arrow that I drew. It's going to hit right here. So it goes there. I'm going to try to make this a little tinier here. So we know that A and B in this picture is different than the first one because they are vertical. So we're going to write A and B are vertical. And we know that vertical angles are always equal. So A equals B. And that's something that you could have used your toolkit to help you with. So we've got some information. This is helping somehow. We'll get there soon, I promise. And then we're doing the last one, taking that A, moving it down with our tracing paper. What you're going to end up is with A right here. And A and B create a straight line together. So A and B create a straight line. So A plus B will equal 180. So we've got some information. Now we're going to kind of formalize it into some names of things and definitions. So 226, it says in problem 225, Althea showed that the shaded angles in the diagram are congruent. However, these angles also have a name for their geometric relationship, their relative positions on the diagram. So when I'm talking about shaded angles, I'm talking about this picture right here, which represented this situation right here. So these angles are called alternate interior angles. They are called alternate because they are on opposite sides of the transversal, and interior because they are both inside, that is in between the parallel lines. So let's talk about that real quick. This is my transversal, and when you, let me use a thinner one so you can see it a little better. So here's my transversal. See how this one's on this side, but this one's on the other side? That's where alternate comes into play. And then I'm going to use a different color. My parallel lines are like this. And notice how my angles are inside the parallel lines. They stay in between here. They don't go outside of them. So that's what interior stands for. So it's in the name is literally telling you where all the things are. So all I'm going to do is write the definition out either in my own words or copy down what it has. That's up to you on that, but I am going to write opposite, let's say angles on the opposite side of the transversal and inside parallel lines. Oop, I'm running out of space. So the other thing with this is there's actually another set of alternate interiors in this picture. So give you a second to wrap that up if you need to. The other set is here. So this was my first set, and then my second are the ones that are on the other side. Sorry, that's not very cute. So let me redraw that so it makes it more clear. So this is my other set here, the blue ones. So you can do both. Okay, so now let's go to the next thing. I already answered it, but it says find another pair of alternate interior angles in this diagram. So we're gonna write them out because we struggled a little bit with that before. So the other pair would be, you have other ways to do this, but we're gonna say D, C, Lots of other ways to write this out. You could have said DCH. You could have said HCD. Lots of options, but I'm going to say DCF. Angle DCF and angle EFC. Okay, so the next part, it says, think about part B. Let me get that all fit in there. There we go. Think about the relationship between the measures of alternate interior angles. If the lines are parallel, and are they always congruent? Are they always supplementary? Complete the conjecture. If lines are parallel, then alternate interior angles are blank. So what we want to do is go back here. And when we looked at this situation, we translated this down because of corresponding angles, but we got that was 48 and this is vertical. So what happens is that is always going to work. So I could do the same for the opposite. I could do the same for this, then I translate it down, and then be equal to that. So it's still going to work every single time. So yes, they're always going to be congruent, not supplementary. So that's helpful, meaning same shape, same size. So yes, they're always equal. So this part, if the lines are parallel, then alternate interior angles are always congruent. So then this next part is kind of useful in the idea that I think I've seen it a little bit on the state test. So I still leave this question here. We don't hit it a lot, but I just want to make sure that you've seen it before. It says part C, instead of writing conditional statements. So conditional statements are if something, then something. If this, then that. That kind of thing. You have to have the if and the then words in it. So instead of writing conditional statements, Roxy likes to write arrow diagrams to express her conjectures. Conjectures are educated guesses. She expresses the conjecture from part B as lines are parallel, arrow, alternate interior angles are congruent. So this is what she has. And this is what we had. So I'm just highlighting the two different things that are representing the same outcome. It says this arrow diagram that says the same thing as the conditional statement you wrote in part B. How is it different? So I'm just going to cross out the things that are the same. So lines are parallel. That's in both of them. Alternate interior angles. That's in both of them. So I'm trying to figure out where they're different. Are congruent. I wrote always, but it's the same thing. So the things that are left are the if and then in the first one, and then the arrow in the second. So the difference is, if then is the arrow in the other one. So that's how it's being replaced. The words if and then become that arrow. So then the next part, part D, it says prove that alternate interior angles are congruent. That is, how can you use rigid transformations to move angle CFG so that it lands on angle BCF. So CFG, if we go back, CFG is right here, CFG. So that's this angle. And then the other one, we're just practicing naming these, B, C, F. So it's just the ones that were shaded. How do we get that, the transformations like we did up here to show that it's going to be equal? Sorry, I'm having a little technical difficulties over here. So we're going to say, okay, take this original angle, CFG, kind of like in the green. Take that angle, and we said translate it down the transversal. So that's the first thing we're going to write. translate. So push angle CFG down along the transversal. And then we're going to talk about the next part of this, which is going back here. We translated it down there, so now it's ended up down here. And then what transformation would get this over here? It would be a rotation. So we're going to say then rotate. So we know that it will be back on top of itself because rotation, translation, reflection, it's all going to preserve that, that shape and size. It's just moving it. So that's telling us it's equal. All right, so we've got one down. Now we got one more. It says 227, the shaded angles in the diagram below have another special angle relationship. They are called same side interior angles. So if alternate interior angles are on opposite sides of the transversal and inside parallel lines, then hopefully at this point you would know what same side interior are. So same side interior are going to be angles on the same side of the transversal. I love that. I love when math terms just like totally make sense. You're like, oh, it says same side interior, so it's like on the same side. Awesome. So it's talking about we're on the same side of our transversal. So these two are on the same side. Cool, cool. And then, and the interior part would be inside parallel lines. So inside right here, the parallel lines. Part A, it says, why do you think they have the same? We already talked about this. I just said that. So Robinson explained. But if you were like doing this in your groups, you would take that time to talk through that. So now part B, it says, what is the relationship between the angle measures of same side interior angles? So it's not necessarily the same as what we just said before for alternate interiors. Are they always congruent, supplementary? Talk about this with your team. Well, that's not an option, so we'll talk about it together. But it says, then write a conjecture, so that's an educated guess, about the relationship of the angle measures. Your conjecture can be in the form of a conditional statement or an arrow diagram. If you write a conditional statement, it should begin with, if the lines are parallel, then same side interior angles are blank. And I'm feeling lazy, so I'm just going to finish that statement and not even write the first part because they already wrote it for me, so that's awesome. But we're going to figure this out by going back to these pictures down here. And the way we're going to do that is this picture right here, if we look back, looks like this one, except those are on the other side. So like these are same side interior also. So they're representing that. So looking at that, if we go back, we decided that if we took A and we moved it down, it was going to end up right here, and the relationship between A and B was 180. Well, when we did that, what that tells us is that every time in this same picture, A and B will always be 180. So if I erase everything, this A and this B will also be 180. So same side interiors will always have that option where you can take this, move it all the way down, and then you're creating this straight line with A and B. So A plus B will always be 180. So going back, maybe, we're saying here, if lines are parallel, then same side interior angles are supplementary because that adds to 180. Oh, I ran out of highlighter. Oh, darn. What shall I do? So they're supplementary, and then if you want to put 180 in there to help you remember, that's cool. Cool, cool. Almost there. Almost to the end. And then you will have a little closure with me, and then you'll get to do some homework. So part C, it says, Claudio decided to prove this theorem this way. So we use like tracing paper and translation to help us out with that. But he used letters in his diagram to represent the measures of the angles. So it says, then he wrote A plus B equals 180 and A equals C. So we're first checking is his work good, and then we're going to explain why. So let's check this first part. Does A plus B equal 180? Yes, because it's a straight line. So straight line is supplementary, and I'm going to just abbreviate that for this part. So we're good on that. That's true. And then A equals C. A and C, yes, those are also going to be equal because they are corresponding. And you could, that's just super abbreviated today, sorry, but they're corresponding. But you could check that by taking tracing paper, tracing A, translating it down, the transversal. Don't you love that? Translate and transversal. Had to pick words that are very close together, but translating it down the transversal, and it's going to go right on top of C. So now it says take all that info, finish Claudio's proof to explain why same side interior angles are always supplementary. So we're going to take all that info and prove it. So we know that A plus B equals 180, and we know that A equals C. And the whole point of it was why same side interior angles are always supplementary. Well, which ones were the same side interiors? The B and the C. So we want to get to B plus C equals 180. That should be our end goal. This has to be what we're getting here. Maybe don't put an equal sign, sorry. That's an arrow. Does that look like an arrow? Nope, nope. It's really bad, isn't it? So this is our end goal. That's a little better. That B plus C equals 180. So let's think about it here. If A plus B equals 180 and A equals C, I could take A and replace it with C. So B plus C, or if you wanted to write it in the other order of C plus B, which means the same thing, equals 180, we're good to go. It's awesome. Really, you don't have to have both to prove it. We used tracing paper in the first page right here to discuss that. It's just another way to look at it mathematically. So, the closure. Just a heads up, we're going to do this here, but then when I come back, we will add it to our toolkit. You are not touching your toolkit now. I want to make sure that's super accurate when we're doing it when I come back. But I want it on here now for later use. So we're going to write alternate interior, later use like for your homework and stuff, and for the practice tomorrow. And the other one's going to be same, oh no, the other one's going to be same side interior. And this is where the color pencils come into play. If you have like your own highlighters or whatever, that's fine. You just need 2 different colors. Please use 2 different colors. It's super useful to have the color coding. Unless you're colorblind, that's not useful at all. So I'm sorry about that. We'll have to find another way for you to label. Oh my gosh, it's moving. Sorry. Okay, so first we're gonna talk about what it is in words, so like explain how to find them. And then we're going to talk about then what's the relationship between them. So alternate interior angles are angles on opposite sides of the transversal and inside parallel lines. Oops. Technically they can just be inside lines, but for them to have a special relationship of being equal, they would need to be parallel. So, if parallel, then alternate interior angles are equal, but I'm going to use congruent today to reiterate our new word. And now is the time for the color coding. So we're going to say C and F go together, and then D and E. So I'm going to write them over here. Oh, love that color. So I'm going to highlight those. C equals F, D equals E. Please write this down. Been doing this for a long time. I think color coding is super useful. So let's try to keep that. I'll give you a second to catch up if you need it. Okay, so then same side interiors, oops, same situation. We're going to talk about what they are, what's the relationship. So angles on the same side of the transversal and inside parallel lines. And like I said, it's really just lines, but parallel is what we're really focusing on here. We're going to write if parallel, then same side interior angles are. Now this is where we have to be careful because everything's been congruent, corresponding, vertical, alternate, they're all congruent, but this isn't. So going back to what we just did, we decided that these add to 180. So a way to remember that, so we're going to write our supplementary adds to 180. A way that I remind students to remember it, I'm going to put it in quotes for you. Same side sup. It like has a ring to it. So say same side sup. Same side congruent, careful. You would actually say same side same, and that would be kind of silly. It would kind of sound silly, but same side sup just like has a nice little ring to it. But we're going to color code again. So I'm going to do C and E, and then D and F. Need a little more here because I'm writing stuff out. C plus E equals 180 and D plus F equals 180. So again, we will be putting this on the toolkit together, but use this as your reference tool when you do your homework. Hopefully you have some time in class to do it.